Next, we are going to solve linear systems of equations by use of elimination. So if you read through the steps here, we're going to make sure each part of our equation lines up. What I mean by that is that we need to make sure that the x's are over top of each other, the y's are over top of each other, the equal sign is over top of each other, and the constant is over top of each other. We're then going to choose one of our variables to eliminate or get rid of. To do this, we need to make sure that they are additive inverses. What I mean by this is they are opposite signs of each other. We're going to combine our equations by adding. I saw a lot of you on the last quiz that did not combine by adding. This is extremely important that you understand. We're combining by adding, not subtracting. We're then going to solve for the variable that remains. Once we find that variable, we can substitute back into our original equation to find the other missing variable. The other thing that I saw a lot of was we didn't write our solution, which is our ordered pair. We need to make sure to do that. So we're going to take a look at number 1 together and work through that, and then you're going to try number 2. So here we go. So as we look at this system of equations, we have 4x is equal to 7 minus 3y. And we also have x plus y equals 7. You can see that the top and bottom equation are not lined up. I'm going to have to take the negative 3y and I'm going to move it to the other side by adding 3y. So I'm going to rewrite this down below. So this is going to become 4x plus 3y is equal to 7. Then I'm going to also bring down the x plus y equals 7. But now I'm going to do a little pre-planning here. I have x plus y equals 7. I can see that neither of the coefficients are opposites of the original equation. So what I'm going to do is I'm going to choose one right now to multiply by. I'm going to take this entire second equation and I'm going to multiply it by a negative 3.
My finger really itches right here.
So this becomes negative 3x minus 3y equals negative 21. Now you can see that the y values are opposites of each other. Since they are opposites of each other, when I combine by adding positive 3y plus negative 3y are opposites, they cancel each other out. I combine the rest of my terms. So 4x plus negative 3x, or 4x minus 3x, is x. 7 plus negative 21, or 7 minus 21, is negative 14. So now I have one of my terms, but remember that when we solve a system of equations, we're finding where the point of intersection would be if we were to graph these two equations. These two equations are linear equations since they have no x squareds or y squareds. So now I know that x is equal to negative 14. I'm going to take that value, I'm going to substitute it back into one of my equations from my original system. The bottom one looks a lot easier, so I'm going to take the negative 14 and I'm going to put it in for that x. So I will have negative 14 plus y is equal to 7. I'm going to add 14 to both sides. When I add 14 to 7, I'm going to get y is equal to 21. I would really like you to write your solution as an ordered pair so that you understand that this is in fact a point of intersection. So my ordered pair, I've got my x value of negative 14 and I've got my y value of 21. So my solution then is negative 14, comma 21. Please try number 2.